Hi guys, this is Mrs. Tellas. We're going to start 7.6 today, which is still factoring a trinomial. We've been factoring a trinomial where the a, that front number, is 1. And now we're going to learn how to factor 1 when a is something other than 1. So I'm going to teach you two methods today. I'm going to teach you guess and check and the grouping. I'll show you both ways and then you can pick the way that you like better and go with that way. Okay, so this is our old stuff, this connection to prior learning. So this is our old stuff. So here we're looking for factors of -3 that give us a sum of b, which is +2. So the only two numbers that I can think of that equal 3 are 3 times 2, or excuse me, 3 times 1. But I need a negative here. They add up to 4, and 3 minus 1 is 2. Okay, so I know I'm going to be subtracting them, and I know I need the bigger one to be positive because the answer or the sum is positive. So I'm going to put my negative right here. So let's see if it works. 3 times -1 is -3. That checks out. And 3 plus -1 is +2. That also checks out. So now I can make my parentheses, my factoring parentheses, and I can put my x plus 3 in the first one, and I got that from right here. And x minus 1 for the back one, and I got that from the second factor. Okay, let's try this one. So this time I'm looking for factors of +2. They give me a sum of 3. And again, I'm taking that from the c right here, and I'm taking that b from the middle. So the only two factors of 2 that I can think of are 2 times 1. 2 times 1 equals 2, and 2 plus 1 equals 3. So we found it. Everything is positive in this equation, so I know that both of the parentheses are going to be positive. So x plus 2 for the first one, and x plus 1 for the second one. These are both factored now. Okay, so what's old about these is this a right here was 1. Okay, what's the new part is that the a in the front is going to be something other than 1. So for example, so I've got 2x squared plus 5x plus 2. So what I do is I multiply a times c. So I'm going to multiply these. So what's 2 times 2? Well, that's 4. So I'm looking for factors of 4 that give me a sum of +5. Okay, so instead of just looking at the c to put that number here, now I have to multiply the a times the c. Well, 4 times 1 jumps out at me. 4 times 1 is 4, and 4 plus 1 is 5. So I found it right away. I know that these are both positive because of the 2 pluses, so I know both of the parentheses are positive too. So it's a little bit different because before I was just taking the 4 and putting it right here and the 1 and putting it right here. But if you notice, this is 2x squared. I can't just put an x and an x in the first position. So these two down here are going to become what's underneath. So I'm going to make the outside 4x. That came from right here. And I'm going to make the inside product 1x. And that came from right here. So I have to think, what could I multiply that would give me 2x squared? Well, that would be 2x times x. It would have to be. So I'm just going to kind of guess and put my 2x here and my x here. And then I'm going to see if that would work. Could I multiply 2x by something over here that would give me 4x? Well, yeah, I could multiply it by a 2. And could I multiply x times something that would give me 1x? Well, yeah, that would be 1. And then I have to check. Does 2 times 1 give me this back c2? And it does. And since they're both positive, this works out perfectly. So this is my factored form of that trinomial. Remember that I could FOIL it to check it if I wanted to make sure it was correct. So I could multiply 2x times x, 2x times +2, 1 times x, and 1 times 2, and then combine like terms. Okay, so that would be the first thing that I could do with guess and check. And now I'm going to do a different problem, but this time I'm going to do it with grouping instead of guess and check. And you might like this method better, or you can go back and forth. It's up to you. Okay, so I start out the same. I multiply 5 times 10, and I get 50. That was A times C, factors of A times C. And then I want sum of 27 in the middle, just like before, and that's my B. All right, so let's start listing them. So 1 times 50 multiplies to 50 but adds to 51. It subtracts to 49, 50 minus 1. So that's not it. Let's try 2 times 25. See, that adds to 27. That's it, isn't it? 2 plus 25 is 27. So that's it because of the 27. So if I'm going to group this, what I'm going to do is I'm going to take the two factors that we figured out, the 2 and the 25 that we used to just put into the parentheses. And now we're going to take this middle term and we're going to change it to these two, the 2x and the 25x. I'm going to replace it, pull the 27x out and put the 2x and the 25x in its place. And the order doesn't matter. It'll work both ways. So I'm going to do 5x squared plus 2x plus 25x plus 10. So notice that the 5x squared just dropped down and the 10 just dropped down. And these two in the middle add up to that one. So it's the same thing, I just wrote it in a different form. Okay, so this is how we do grouping now. So we look at the first two terms right here. And we ask ourselves, what is the GCF of these two terms? So this takes us back to 7.4, which was a while ago. So 5 and 2, there's no number besides 1 that I can factor out. The first term has an x squared and the second term has an x. So that means that I could divide an x out of both of them. So I'm going to divide x out of both. So I'm going to do divide x here and divide x here. Well, if there's two x's on top and there's one x on the bottom, that only leaves me with one x. So that first term would be 5x. And if there's both of these x's here, top and bottom, they cancel, and that leaves me with plus 2. So I factored a GCF out of the first two terms. And now I'm going to do the back two terms. So these two. So I'm looking for a GCF for 25x and positive 10. Well, notice that the 10 doesn't have an x, so there's no letter that will come out of both. But there is a number that will come out or be factored out of both. So they both have a factor of 5. So let's try to pull a 5 out. So I'm going to put positive 5. And I'm factoring a 5 out of the front one here and the back one. So 25x divided by 5 would be 5x. And positive 10 divided by 5 would be positive 2. I hope you notice that these match. This one and this one match. 5x plus 2 and 5x plus 2. When you get that matching factor on the inside, that means you're right. So you'll write that one down as one of the factors, 5x plus 2. And then the other factor will come from the two GCFs that you divided out. So x plus 5. And this is my answer. Some of you will like guess and check better. Some of you will like the grouping better. Up to you. And here are the steps. If you want to write them down, you're more than welcome to. If that would help you later, that would be great. You can press pause and go ahead and write those down. All right, so number 3, and what I'm going to do is I'm just going to go back and forth from guess and check to grouping, and whichever way works for you, you do that on your paper. After each one, you can press pause and give that a try your way if it's not the right way that I'm doing it. All right, so we're back to guess and check here. So I'm looking at this one. It's got a big number in the front, 24 for A. So I'm going to multiply 24 times 3, which is 72. And I want factors of 72 positive that give me a sum of negative 22. So what I know about this is that both of them are going to be negative, because a negative times a negative is a positive. And also when the signs are set up where the back term or the C is positive and the B is negative, that means in the parenthesis that they're both going to be negative. I know that for sure. Okay, so whatever it is, I'm going to multiply something times something. I want it to add up to 22. So let's start listing them. So 1 times 72 does not add up to 22, it adds up to 73. If I subtract them, it gives me 71. 72 minus 1, that's not it. So 2 times 36, well, that adds up to 38, and it subtracts to 34. Getting a little closer, but that's not it. So 3 times, let's see, 24? Yeah, that adds to 27, and it subtracts to 21, which doesn't work. I want it to be 22, but I'm really close. So let's try 4. So I'm going to use my calculator. 72 divided by 4 is 18. So 4 times 18. Well, if I add them, I get 22. Hey, do you notice that I'm trying to get 22 up here? Those are that's the 22, so that means those are probably my factors. I just need to arrange my signs now. So they both multiply to 72, but they don't add to negative 22. And I want them to, so I'm going to make this one a negative and this one a negative, and then try it again on my calculator. So negative 4 plus negative 18 equal negative 22. So that's the big winner. That's the factor that I want to use. So over here, I'm going to put negative 4x on the inside and negative 18x on the outside. So when I multiply these two, it's going to equal negative 18x. And when I multiply the insides, it's going to equal negative 4x. So the easier one to start with is back here, because there's only two factors of 3. 1 times 3. So I have to put those in the correct position. So I'm going to kind of guess where I think I should put them. But I'm going to use some strategy. So I know that I have to put the 1 and the 3 back here. I just don't know what order. So here I need these two to multiply to be 4. Well, there's nothing that 3 times anything will give me 4. That's an integer. So I'm going to put the 1 here and the 3 here. And if I put them in the wrong spot, I would just switch them later and see if I could figure it out. Okay, so now once I get the first two in there, now I know that 3 times something is going to give me 18. So I'm going to put my 6x here. 6x times negative 3 is negative 18x. That one checks off. So now I have to figure 6x's partner that has to go right here that will equal 24x. So 6 times 4 is 24. So let's try 4x right here and see if that works. So 4x times negative 1 is negative 4x. So that is the factored form of that trinomial. And again, if I wasn't sure and I wanted to check it, I could FOIL it. All right, number 4, let's do grouping this time. So I'm still going to multiply a times c, and I'm looking for factors of negative 15 that give me a sum or a difference of 14. So there's nothing really that the signs tell me other than that probably that they are going to be opposite signs. One's going to be a plus and one's going to be a minus. They're different because of the way the sign setup is. So let's start with 15. So 15 times 1, when I add them, I get 16, and when I subtract them, I get 14. So I know that I'm going to put a negative with one of these for several reasons. First of all, because I have to subtract them to get 14. And secondly, because 15 times 1 is positive 15. So I'm going to put the negative in. And because this is a positive 14, I'm going to give the negative to the smaller number, to the negative 1 right here. So let's see if it works. Negative 1 times 15 is negative 15. That part checks out. And 15 plus negative 1 is 14. So we found our factors right here. We're going to use 15 and negative 1. So let's make our parentheses for our guess and check. Oh, actually, are we grouping here? Yep, we're grouping here. So we don't want those parentheses yet. Hold on. Okay, so that means we're going to take this middle term, 14x, and we're going to change it to 15x and minus 1x. So 3x squared is copied exactly how it was, plus 15x minus 1x minus 5. And you could put these in either order. I only put the 15 first because it was first in my T-chart. But if you put it in the other order, the negative 1x first, that would still work if you do your GCFs correctly. So now I'm going to look at the first two terms, and I'm trying to find the GCF for those. So the highest number that I can divide out of 3 and also out of 15 is 3. And the highest amount of x's I can divide out, because there are 2 here and 1 here, is x. So I'm going to divide both of these terms by 3x and see what I have left when I do that. So those 3's are going to cancel. There's 2 x's on the top and 1 x on the bottom, so that leaves me with an x. And back here, 15 divided by 3 is positive 5, and the 2 x's are exactly alike, so those cancel. So that's my first part. So now let's change colors, or at least try to, and factor out of the back. Okay, so looking at here, I can't take an x out because this one doesn't have an x, but I can take a -1 out of both of these. I can divide a -1 from the front one and the back one. So if I divide a -1 here and a -1 on the -5, that leaves me with x plus 5, which if you notice, these match exactly. So when I get to this point and they're matching, I know that I'm right. So the matching ones is one of the binomials, and the 2 GCFs put together in the same parenthesis is the other one. So 3x minus 1. This is the answer. All right, number 5. I'm going to go back to guess and check here. Okay, so and if you would like to stop the recording and try it by yourself, I think it's a really good idea. Even if you're grouping, you're still going to get the same answer that I'm going to get with guess and check. So it's completely up to you how you do that, whether you use guess and check or grouping, but I'd really like you to try number 5 by yourself before you watch me do it. So I'm looking for factors of -12 because I multiplied 4 times -3 that give me a sum or a difference of 4. So I'm going to start listing factors of 12. So 1 times 12, if I add those, I get 13, and if I subtract them, I get 11. I always do the big one minus the little one, and right now I'm not messing with that negative. I know one of them has to be, but I'm just trying to figure out the number 4 over here first, and then I'll mess with my negatives. So 2 times 6. If I add them, I get 8, and if I subtract them, I get 4. Ooh, that might be it. Okay, so we know it's not the add one, and we know it's not that top one. So we need to figure out where we could put our negative, because 2 times 6 is positive 12. We need one of them to be negative. So I notice over here that this is positive 4. So since this is positive 4, that means the negative goes with the smaller one. So let's see if it works. -2 times 6 is -12. That works. And -2 plus 6 is 4. That works too. So this is the correct answer for the factors. So let's put our numbers in here. So I'm going to put 6x down here and -2x here. Okay, so I'm going to start with this C because there are only 2 factors of 3. 1 times 3. There's no other choices. So I don't have any other choices to put there. So I'm going to try to finagle and put those in the right place. Okay, I'm not sure on the signs either, so I can't just slap some signs in there yet. So if I put the 3 here and the 1 here, and I'm just guessing, then I look at the bottom and see if that's a possibility. So 3 times something, would that give me 6? Yeah, that would work. And 1 times something, would that give me 2? Yeah, that would work. And the 2 is coming from here. I'm not really looking at the signs right now. Okay, so let's go over here. So I need 3 times something that will give me 6x, but I need it to equal this one times this one need to equal 4x squared. So my only possibilities are 1 times 4 and 2 times 2. Well, I need a 2 right here because 2x times 3 is 6x. So let's try 2x times 2x because these two have to multiply to that. And they do. So now let's check to see if it works. So 2x times 3 is 6x, and it's supposed to be a positive 6x. That means that 3 is supposed to be positive. And 1 times 2x is 2x, and it's supposed to be negative, so I'm going to put a minus there, and that will take care of it. So this is the answer. If you got that before I did, nice job. Give yourself a pat on the back. Also, you could check it if you wanted to using FOIL, if you wanted to make sure it was correct. All right. Notice the directions here changed. You don't just say factor anymore. Notice that these have an equal sign and a number on the right. Remember, in order to solve, the number on the right must be 0. We're going to factor the exact same way, and then we're going to take our 2 parentheses and set them equal to 0 and solve. So this is just another step, similar to what we did in 7.5. First we learned to factor, then we learned to solve. So let's work on this one. So I'm going to multiply 4 times negative 35. And I'm going to use my calculator for that because I don't know my 35s. So 4 times 35 is negative 140. And they need to add up or subtract to negative 4. Okay, so if I start listing, now this is a really small number, so I could do 1 times 140, but there's no way I'm going to be able to get 4 with that. So I'm thinking maybe 10 and 14. Let's see if that works. If I add them, that gives me 24, and if I subtract them, it gives me 4. So I'm thinking that works. I need a negative because 10 times 14 is 140, positive 140. I need it to be negative. And I want this to be negative 4 because that's what it's supposed to be in the middle. So that means the bigger one has to be negative. So I'm going to put my negative with my 14 and then see if it works. 10 times negative 14 is negative 140. And then if I add them, 10 plus negative 4, or negative 14, that gives me negative 4. So these are my two factors that I want to use in place of grouping because we're doing this one with grouping. So we'll do 4n squared plus 10n minus 14n minus 35 equals 0. So again, remember what I'm doing. I'm taking that middle term out and I'm replacing it with the factors that I came up with over here. I'm just taking these and putting them in here. And if you have it the other way with the negative 14 first, that is okay. It will still work. All right, so now I'm looking at the front two, and I want to take out the GCF. So the highest number I can take out of 4 and 10 is 2. And the most amount of n's that I can divide out is n, just 1. So I'm dividing each of these by 2n. When I do it to the first one, that gives me 2n. And when I divide the second one by 2n, I get 5. So now I want to try the back two, the negative 14 and the negative 35. So I'm thinking 7, negative 7, actually, since they're both negative and I want it to match this one. So let's try to divide out a negative 7 and see what that gives us. So if we divide out negative 7 for both, that would leave me with 2n. So far that matches, that's good. And the back part would be plus 5, and it matches. So I know that I'm right. So see how these match? So that means that's one of the terms. So 2n, there we go, 2n plus 5. And then remember, I take the two GCFs and I make the other binomial, 2n minus 7 equals 0. Now, since it says I have to solve, I'm not done. I factored it. The factoring was just a way to get the answer. So 2n plus 5 equals 0, and 2n minus 7 equals 0. So this is just a two-step equation. In fact, I don't think there's enough room here, so I'm going to scooch it over. I have a little bit more room to solve. So I'm going to make my t. I need to subtract 5 on both sides and divide by 2. So n is negative 2.5, or you could have left it negative 5 over 2. Either way works fine, fraction or decimal. And then I'm going to add 7 to both sides. So that's 2n equals 7, divide by 2. So that's 3.5, or just 7 over 2 if you like that fraction better, up to you. So I do the same thing I did on 1 through 5. I still factor, either using guess and check or grouping. But then once I get the two binomials in the parentheses, I set each of those equal to 0 to find the final answers. Whoops. Let's get rid of that. Oh, a big old line across there. Okay, number 7. All right, notice that this is still factor and solve, but we have something over here on the right other than 0. So I need to move this negative 13x to the left side with the trinomial. So I'm going to add 13x to both sides. Notice there are no other x over here. There's a 2x squared and there's a constant. So I'm going to slide it between so it's in standard form. So 2x squared plus 13x plus 20 equals 0. Now it's in the right form so that I can factor it. And I'm going to guess and check. So I'm multiplying 2 times 20, which is 40, and I'm trying to figure out factors that will give me 13. So I start listing them. 1 times 40. If I add them, I get 41. If I subtract them, I get 39. That's not it. 2 times 20. If I add them, I get 22, and if I subtract them, I get 18. That's not it, but I'm getting closer. 3 is not evenly divisible by 40. How about 40 is not evenly divisible by 3? And let's try 4. 4 times 10. If I add them, I get 14. And if I subtract them, I get 6. I'm closer. Let's try 5. 5 times 8. If I add them, I get 13. That's it. Notice there's not a negative in this problem, so that means that both of them are going to be plus. So positive 5 times positive 8 equals positive 13 when I add them. So those are the correct factors. So let's make the inside 5x when I multiply, and the outside's 8x when I multiply. So neither of these are prime. Well, actually 2 is. 2 is prime. So let's see. Let's put 2x here and x here. So let's see if that will work for me. So x times something gives me 5x. I'm going to put a 5 here. And then 2x times something gives me 8x. I'm going to put a 4 here. And let's see if that works. 5 times 4 is 20. That totally works. Everything's plus, so we get a plus in here. And let's make sure it works on the bottom. Positive 5 times x is 5x. 2x times positive 4 is 8x. So that's totally right. That is absolutely the correct factors. So now I have to solve them. So 2x plus 5 equals 0, and x plus 4 equals 0. So I'm going to subtract 4, and x is negative 4. And I'm going to subtract 5 and divide by 2. So x is negative 5 over 2, or negative 2.5 if you prefer. One more on this page. We'll group it, and then we'll wrap this up. All right. Again, the directions are factor and solve. Negative 4 is over here by itself, and 0 is supposed to be on the right. So I'm going to add 4 to both sides. That leaves me with 9g squared minus 12g plus 4 equals 0. Now it's in the right form. So I'm looking for factors of 36 that give me negative 12. I know from the sign situation that both of them are going to be minus or negative in the middle. Okay, I know that for sure because a negative times a negative is a positive. But when I add a negative and a negative, I get a negative. I just need to figure out what the numbers are. So 1 times 36, when I add them, I get 37. That's not it. 2 times 18, when I add them, I get 20. That's not it. 3 times 12, when I add them, I get 15. That's not it. 4 times 9, when I add them, I get 13. That's not it. I'm close, though. How about 6 times 6? When I add them, I get 12. Okay, now let's deal with the sign. This is it, but we've got a negative 12 here, which means that both of these have to be negative. Negative times negative is positive 36. And then negative 6 plus negative 6 is is a negative 12, which is what we wanted. So they're both negative. Okay, so we want, underneath here, we want to put negative 6x and negative 6x. And it equals 0. So we still have to solve it once we figure out this part. All right, so 9. Let's start with 9. So we've got 1 times 9 and 3 times 3 to choose from. They both have to be 6. I don't know 9 times anything that gives me 6. But I'm thinking 3g and 3g. That equals 9g squared. Okay, and then here, if I want it to be negative 6, this is a g, not an x. Whoopsie. We'll put 2 here. 3 times 2 is 6. And same thing over here, 2 here. 2 times 3 is 6. I've already got my negatives in there. Let's see if everything works. So negative 2 times negative 2 is positive 4. That works. Negative 2 times 3g is negative 6g. That works. Negative 2 times negative 3 is negative 6g. That works as well. So notice that they're exactly the same. So I'm just going to do one of them. So 3g minus 2 equals 0. So I'm adding 2 to both sides. Oops, that's a 2 now. And dividing by 3. So g is either 2/3, or if you want to change it to a decimal, 0.6 repeating. Either one of those works. Those my final answer. Okay, I've got an application problem here. If you want to give it a try, you can. If you'd like to skip it, that's also okay. You do have one application problem in your homework today. It's a story problem, and you're going to factor the trinomial that's given. So you could either use grouping or guess and check here if you'd like to. All right, so if I write it down here, it says the area of the knitted blanket is 15x squared minus 14x minus 8. What are the possible dimensions of the blanket? So we have to factor this trinomial. So we have to multiply here. 15 times 8, let's see, using my calculator, is negative 120. And we want those factors to add or subtract to negative 14. All right, so let's start listing them. I'm sure there are a lot of factors to 120. So 1 times 120. And right now I'm not messing with any signs. I'm just looking at numbers. I'm trying to find two factors that'll give me either a sum or difference of 14. So that's 121 if I add them and 119 if I subtract them. Let's do 2 times 60. If I add them, that is 62. If I subtract them, that is 58. Not working. How about 3? If I add them, I get 43. If I subtract them, I get 37. We're kind of far away still. How about 4? If I add them, that's 34, and if I subtract them, that's 26. Doesn't work. How about 6? Oh, I skipped 5, didn't I? I think I'm going to go with 6 anyway, because I think 6 is it. 6 and 20. If I add them, it's 26, and if I subtract them, it's 14. That's got to be it. Not the 26, but the 14. So we've got negatives everywhere. So let's figure out the sign. So none of these worked. I couldn't get the numbers to give me 14. But this way, I could when I subtracted. Okay, so which means one of them is going to be negative and one of them is going to be positive. So we want this number on the right, the negative 14, to be negative, which means the bigger one has to be negative. So I'm going to give the negative to the 20 and see if it will work in my table. So 6 times negative 20 is negative 120. That works. And 6 plus negative 20 is negative 14. That also works. So these are my factors I want to use down here for my parentheses. Notice I'm not solving this one, I'm just factoring it. Okay, there's no equals 0 here. So let's put our 6x here and our negative 20x down here. So let's see, I think we'll do 15. So I've got 1 times 15 and 3 times 5 to choose from to go in these two spots. So I'm kind of thinking we're going to do the 3 and the 5 because 15 times nothing is 6 or 15 times nothing is 20. So let's do the 3 and the 5. So let's put the 5 here and the 3x here. Let's see if that choice works out. 5 times something's got to give me 20. That would be 4. And 3 times something's got to give me 6. That would be 2. 3 times 2 is 6. So let's see if it's right. So this is supposed to be 6x and it's supposed to be positive. So that would be a plus. And these two outsides are supposed to be negative 20x, which makes that a negative. The last thing I need to make sure is that 2 times negative 4 is negative 8, and it totally is. So these are the dimensions of my blanket. 5x plus 2, and the other one is 3x minus 4, which I know is kind of weird because it's a blanket, but it's just the story problem. Okay, we're all done. Okay, so your assignment is in Big Ideas. It's online just like it always is. It's page 350 or 395, 9 to 22 all, and also number 24. If you need help, like always, I'm on Canvas online conferencing Monday through Friday from 11 to 12. I'm happy to help you if you need it. Please come see me. All right, take care. Bye-bye.